Okay, in these examples right here, we're going to look at neutralization reactions, and we're going to look at these through the scope of an acid and base, and when these come together, we call them neutralization reactions because they think of it as canceling each other out. So we will have an acid plus a base, and then your products will be water and an ionic compound. Now, I'll do this first question first. So you have one of two ways you can solve this. So option one, and then because your acid only has one hydrogen and your base only has one hydroxide, you can do it this way where you do M1V1, M2V2, where the M is the concentration, V would be volume. So in this question, it's asking what concentration of hydrochloric acid. So that's what we're solving for. This will be my X. And we are going to use a volume of 100 milliliters. I'm going to put this in terms of liters. So how much of that will we need, or what concentration of that will we need to neutralize a 3 molar solution that has a volume of 0.101 liters. So you can solve this pretty simply. So you'll have 3 times 0.01 equals 0.1x. So you'll have 0.03 divided by 0.1. So the concentration that we need would be 0.3 molar. So that's the first option. Option 2 would be with using stoichiometry. So let me make this smaller. Okay, so with this option 2, we're going to look at what we're given. So I'm going to erase some of this. So we can't figure out, we don't know the amount of moles of hydrochloric acid, but what we do know, we can figure out the number of moles based off of these two values. So if you remember that your molarity is equal to number of moles over the volume in liters, you can figure out the number of moles. So my molarity is 3. X, I'm going to put for a number of moles, and my volume is 0.01. So now you can take this and you can multiply 3 times 0.01. So we'll get 0.03 moles of NaOH. I'm going to move this over. Now I can do this like I would do any other stoichiometry question. Put that over 1. This will go at the bottom. So the thing I forgot to do was write out this equation. So let me make this smaller and then write out this equation. Make sure it's balanced. Two, 1. Okay. So the coefficients would just be 1. So you have 0.3 moles of NaOH, and here we're going to put mole ratios go down here. And it's a 1-to-1 ratio. I don't know why I put these over here. Okay, so we're going to set this up like this. So this is starting to look like all the other stoichiometry questions we've done. Okay, so in here we know we're given 0.03 moles of sodium hydroxide. and it's a 1-to-1 mole ratio. We multiply across 0.03 divided by 1. So we will need 0.03 moles of HCl. Now, we're not finished with that because the question, what they're asking is what concentration. So now we have to go back and look at this formula and look at what we are asked in the question. So 0.03 moles and the volume 0.1 liter. And how I put that to liters, 100 milliliters is 1/10 of a liter. Now this will give you a molarity of 0.3. So we solved with 0.3 right there, using M1V1 equals M2V2, and then we solved and got 0.3 right there using stoichiometry. So you have one of two ways you can solve this. If you are given something basic, or something basic in terms of when these disassociate, you'll just have one proton just floating around and one hydroxide group just floating around. Then you can use option 1 or 2. When they get more complex, then you're going to have to start using option 2, doing it with the dimensional analysis the way that we do stoichiometry questions.